Modern refrigeration and air conditioning. Chapter 22, Refrigerant Flow Components. Explain the two primary functions of refrigerant loop components. Describe the purpose and use of liquid receivers. Differentiate between the distinct duties of filters and dryers. Explain the function of a suction line and a liquid line filter dryer. Explain how sight glasses can be used to indicate the amount of moisture in the refrigerant system. Describe the operation and use of refrigerant line valves, shutoff valves, service valve, check valves, solenoid valves, hot gas defrost valves, hot gas bypass valves, and liquid injection valves. Explain the operation and purpose of a crankcase pressure regulator. Compare the operation of the different types of evaporator pressure regulators. Compare and contrast the different types of relief valves available. Describe the different head pressure control valves and condenser arrangements and explain how they operate to maintain head pressure. Refrigerant loop components. Basic HVAC-R system only requires metering device, evaporator, compressor, and condenser. Primary function of a refrigerant loop components to control refrigerant flow, maintain proper refrigerant quantities and qualities, flow control components, solenoids, pressure regulating valves, etc. Quality and quality components, filter, dryers, liquid receivers. Suction line filter dryers. In most cases, the only time you use a suction line filter dryer is usually when you're having a problem. In most cases, it's a compressor burnout where the wiring and windings inside burn and put contaminants into the system. Liquid line dryers usually don't filter particulates as well as a suction line dryer because the liquid's moving so quickly through the line. Well, the suction line dryer, remember, it's a low pressure side of the system between the evap coil and the compressor. So it does a much better job at filtering, but there's a problem with that. They do get clogged easily. That's why normally and you should use ones that have access ports on both ends. That way you can compare the pressure to one side and the other. These will have to be changed out. Normally, when you have a burnout, you put it in for about a month and then go back out and take it out of the loop. It is a lot more work, and unfortunately, it's going to have to pump down the refrigerant or reclaim the refrigerant to do this. But they clog very easily, and since the pressure is so much lower, it can cause a lot of problems with starving the compressor for refrigerant. This presentation makes a very good point. There's a caution here. Suction line dryers and dryers in general need to be cut out of the system and not brazed out. If you overheat the material, the desiccant inside the dryer, it can release the particulates and the moisture in the system and cause it to foul up the system down the line. So it's a really good reason just to use your cutters, cut it out instead of using a torch. Liquid receivers. A tank connected between the condenser outlet and the liquid line, used for refrigerant storage and pump down, must provide enough room for all refrigerant in the system. Your pictures you can see a little bit better in your book than you can on this slide. Liquid line filter dryers. Filter and absorb contaminants to remove them from the system. Absorption, the ability to collect and retain gas or vapor substances on the surface of solids or liquids. Works through physical action and capillary action. These are a lot like the suction line dryer. When this, you'll find, you'll see, and if you happen to have a sight glass on, when you see bubbles in a sight glass, it's usually because there's moisture and these items have stopped doing their job, both the filter and dryer for the suction line and liquid line. So, or if you have a major drop in pressure, those are the times that you need to replace either one of these dryers. Sight glass and moisture indicators. Sight glass view port installed in a refrigerant line, so you can actually see the refrigerant going by. Seeing bubbles is usually usually what you'll see when it's low on refrigerant, or if there is a clog in a dryer. The moisture indicator on some of these sight glasses changes color when there's moisture in the refrigerant. Caution. Moisture indicators are sometimes different colors used by different manufacturers. So sometimes you'll have to use the internet to figure out whether or not the system is telling you there's moisture in it. And it's just something you have to check when you're looking at a specific sight glass. Refrigerant line valves control the flow of refrigerant through the system piping, used for selection, isolation during service work. Types are two-way and three-way. And all our condensing units that I know of in our lab have these on them. They look a little differently, but they're still refrigerant line valves. Shutoff valves allow or block refrigerant flow through the individual evaporators. Manifold valves, suction line manifolds, liquid line manifolds. Riser valve control refrigerant flow through vertical lines. These are real common in commercial refrigeration systems or anything you see in the way of coolers for dairy products or frozen foods. And sometimes these are controlled by a solenoid where they turn off automatically when the system shuts down. Service valves seal off parts of the system, provide a connection for a system for taking pressure readings, adding or removing refrigerant or oil. Locations are on the suction line, discharge line, liquid line, inlet of a liquid receiver, outlet of a liquid receiver. And those are called king valves. It's normally what you see on most residential condensing units. Check valves permit the flow in one direction only, prevents refrigerant from migrating back where it's not supposed to go. May be installed in evaporator outlets, multi-evaporator systems, bypass metering devices, and heat pumps, some discharge line. Anytime you see a multi-evaporator unit, they will have to have a check valve so the refrigerant doesn't flow into another unit that's not operating at this time. Solenoid valves. Valve bodies equipped with electric coil, energized electromatic lifts, plungers to open a fluid passage, automatically controlled valve, numerous of HVACR applications. You see these in almost every refrigeration unit. That's the condensing units on the roof. and the VAP coil is built into a walk-in cooler or a reach-in cooler inside the store or facility, because you do not want the liquid refrigerant, once the system is turned off, to run back into the evap coil. So you try to stop that by the system, when it shuts off, it shuts this valve so refrigerant stays inside the outside condensing unit. This is showing you a breakdown of the solenoid valve. How down the circuit opens, the valve closes. Circuit closes, the valve opens. Three-way solenoid valves, mainly used on commercial systems. Common use is hot gas defrost to prevent intermittent TXV opening. So a chapter or so ago, we talked about heat exchangers and evap coils. Some of them have a hot gas defrost line. So the hot gas defrost line, when the system goes into frost, it will switch the system to push the hot gas from the compressor to the INSOR evap coil to defrost the coil. Reversing valves. Four-way solenoid valves used to reverse flow through the heat pumps. Most use pilot valve to operate piston. High and low pressure move pistons to change inner passageway. We talked a little bit about this in the labs for this module, and you'll start seeing these more and more. Florida doesn't have a lot of heat pumps, but they do exist. And the one thing I can tell you about them is the worst job that you'll run into, because they're so difficult to remove 3 soldered on 3/4 to 7/8 inch lines at the same time. Unbrazing them is a real problem, but they are difficult to work with, but luckily in Florida we don't have a lot. So you might not get a lot of opportunity to do one of these.